Now let's go back to our example and look at part B, which involves an interval estimation. With a 95% interval, estimate the expected vacancy rate in a city if the average monthly rent per square foot is $3.50. Okay. Note above that the vacancy rate, which is called V here, V is the Y variable, so the vacancy rate is the Y variable. Okay, so in front of that we have expected, so this is the expected value of Y given X. So let's, for right now, reproduce that and change it up. So the vacancy rate, we can replace vacancy rate with Y. If the monthly rent and monthly rent from above, office rent is the R, and R is the X variable. If X is $3.50, okay, so this is a confidence interval. It's asking for the expected value of Y given X of 3.5 and a 95% interval estimate. In this case, confidence interval. Alright, so let's go to our worksheet and start that off. Okay, so we want a 95% confidence interval for the expected value of Y given X of 3.5. Let's first do the point estimate. So we write down our regression. Y hat is equal to beta hat 0, 16.71 was given to us, plus beta hat 1, which was a negative 2.714, times the X, and our given X was 3.5, and the result there is 7.211 for the point estimate. Alright, let's write down our formula so that we know what we need. So this is a confidence interval. Y hat plus or minus the appropriate t value, n minus 2 degrees of freedom, alpha divided by 2 on the tail, times s of e times the square root of 1 over n plus x minus x bar squared divided by sum of squares of x. Alright, since it's a 95% level of confidence, this means that the alpha is 100% minus that level of confidence, 95%, so the alpha is 5%. So the t that we have here, again, 10 minus 2 or 8 degrees of freedom, and 2.5% of the tail, just like the test we just did. That's 2.306, and all the other bit of information we already have. Alright, so we need standard deviation of the errors, and we worked that out before at 1.651. We need n, of course, which was 10. The x was given, that's the 3.5, x bar 3.725, and again from before, sum of squares of x, s of xx, which is 7.681. Okay, so now let's fill out our formula. So y hat from above, 7.211, the value comes from up here, plus or minus the critical t value from the table, 2.306, times s of e, 1.651, times the square root of 1 over n, 1 over 10, plus x, the given x, 3.5, minus x bar, 3.725, square that difference, and divide by the sum of squares of x, sum of squares of x being 7.681. Okay, and of course remember we want the square root of that whole thing. Okay, so let's now work that out. And that works out to be 7.211 plus or minus 1.243, and that becomes 7.211 minus 1.243, which is 5.968, and then 7.211 plus 1.243, and that turns out to be 8.454. Okay, so this then is our 95% confidence interval. And if you want an interpretation or a feel for what that means, you can say something as follows. We are 95% confident, and we could use that beginning part and the word confidence even for a prediction interval. 95% confident that the expected vacancy rate is somewhere between 5.968, and these are percentages, so percent, and 8.454%. That doesn't mean that the actual vacancy rate will be then in there, but the expected value will be somewhere between 5.968 and 8.454%. Okay, and that's the end of that example.